China's Navy continues to expand its foothold, challenging rivals in the contested waters of the South China Sea.
China has suffered a significant blow to its naval ambitions. Its most advanced nuclear-powered attack submarine.
What if a fleet could dominate the sea without ever being seen, or even existing physically? China's latest naval breakthrough merges radar illusion, robotics, and AI to create something entirely new. Ships that don't need humans, or even need to be real. This isn't science fiction, it's a real-world shift in how maritime power operates. In this video, we'll explore how China is rewriting the rules with ghost fleets. In recent breakthroughs, Chinese researchers developed an innovative radar decoy system that makes a single ship appear as an entire fleet. Unlike traditional jamming systems that overwhelm sensors with noise, this new approach relies on simple, elegant deception, creating ghost signals that mimic real ships in every measurable way. The system, revealed in 2025 by the Beijing Institute of Telemetry, involves swarms of ultra-lightweight emitters using just 1-bit processors. These devices are deployed near a warship and generate electromagnetic signals calibrated to resemble full-sized naval vessels. The real magic lies in their coordination. Each decoy emits a signal that, when combined with others, builds a synthetic radar image of an entire fleet formation. Instead of merely confusing radar systems, these decoys overwrite reality. Enemy sensors don't just see false blips, they see convincing formations moving in synchronized patterns. When enemy radars detect the decoy array, they register it as an actual, dangerous presence. These illusions can trigger alerts, misdirect tracking systems, and cause automated targeting to prioritize the wrong targets. This approach was tested in a simulated exercise involving a Chinese Type 055 destroyer. The decoys were deployed around the vessel while it cruised in contested waters. When scanned by synthetic aperture radar simulations, the ship appeared to be accompanied by a formation of 5 other large vessels. The destroyer was not only shielded from tracking, it appeared stronger and more threatening than it was. Defensive systems might lock onto the decoys instead of the actual ship. Surface drones, submarines, and aircraft may spend critical time and resources targeting ghosts. And perhaps most significantly, real-time decision-making becomes clouded by uncertainty. Even a few minutes of hesitation caused by radar illusions could completely reshape the outcome of an encounter, or, at the very least, divert attention at a crucial moment. While the system currently focuses on radar deception, it's designed to scale. Future iterations are expected to include sonar and infrared decoys, effectively covering multiple domains of sensor detection. This would mean complete electromagnetic camouflage for surface fleets. By using 1-bit chips, far less advanced than those found in smartphones, China has created a system that's cheap to mass-produce, difficult to detect, and easy to deploy. This flips a long-standing rule in electronic warfare. More complexity isn't always better. This is just the first layer of China's evolving strategy. Radar illusions may hide or misrepresent existing assets. But what happens when the vessels themselves are also autonomous, intelligent, and don't rely on any human crew? Let's explore that next. China's Navy isn't just using deception. It's building a whole new generation of surface vessels that operate without any onboard personnel. These are not prototypes anymore. They're modular, combat-ready, and designed for real-world missions. The centerpiece of this movement is the Yari USV, a sleek, multi-role unmanned surface vehicle that's as versatile as it is autonomous. The Yari USV, which stands for Joint Autonomous Research Institute vessel, it is about 15 tons in weight and roughly 15 meters long. It may look like a small patrol boat, but its capabilities are anything but small. It features a modular weapons bay, phased array radar, vertical launch systems, and sonar. It can perform anti-submarine, reconnaissance, and even defensive support roles. Most importantly, it's designed to operate fully without a human crew. This vessel runs on an artificial intelligence system that allows it to assess its environment, adjust course in real time, and even respond to unexpected threats. While it can be remotely piloted when necessary, it's designed for autonomous operations, capable of functioning in coordination with other similar vessels. One of the most compelling aspects of the Yari USV is its ability to operate in swarms. These vessels can share data and distribute responsibilities like surveillance, electronic monitoring, or decoy deployment. If one unit detects a potential object of interest, the swarm adjusts its behavior. Some tighten formation, others fan out to investigate. This removes the need for centralized command in dynamic situations, dramatically reducing response time. Recent tests showcased this in action. In a coordinated drill off the Chinese coast, 3 RUS simulated a complex response pattern to a moving target. Within seconds, the swarm repositioned itself, locked sensors on the target, and relayed data to other units. It was a live demonstration of distributed intelligence on the water without human intervention. Strategically, this changes everything. Conventional warships require dozens or hundreds of crew. They have logistical needs: food, air, rest, and safety protocols. These unmanned vessels eliminate all of that. They're smaller, lighter, cheaper, and can remain deployed for longer periods without risking human life or morale. If one is lost, it doesn't result in human tragedy. It's simply a tactical loss, not a strategic failure. These vessels also open the door to high-risk missions that would otherwise be avoided. Need to scout a dangerous area? Send a USV. Want to test enemy radar response without escalating tension? The level of flexibility this adds to naval strategy is enormous. But these unmanned ships don't just act alone. They're part of a larger, integrated system that includes air-based platforms as well. And that leads us directly into the next major leap in China's Ghost Fleet. Drone-carrying ships that don't launch planes, but launch autonomous squadrons. Imagine a ship that doesn't carry fighter pilots, but instead launches fully autonomous aerial vehicles with stealth features and advanced targeting systems. That's exactly what China is developing with its new class of drone-launching ships, particularly the Type 076 platform. These vessels are designed to operate a new breed of flying machines, the GJ-11 Sharp Sword, a flying-wing stealth UCAV, unmanned combat aerial vehicle. The Type 076 is unlike conventional amphibious ships or aircraft carriers. It incorporates electromagnetic catapults, similar to those on China's Type 003 aircraft carrier, but optimized for drones. This allows the vessel to launch and recover fixed-wing UCAVs efficiently without needing human pilots or legacy support infrastructure. The GJ-11 drones it launches are capable of stealth missions, surveillance, and precision strikes. Their flying-wing design makes them hard to detect on radar, while internal weapons bays keep their profile low during missions. Once launched, they don't rely on constant uplinks to command ships. They make decisions independently based on real-time sensor data. What makes this combination so unique is how it integrates into a broader network known as a kill web. In recent war game simulations, a Chinese destroyer equipped with AI sensors coordinated attacks alongside USVs and GJ-11 drones. The simulated scenario involved defending a maritime route against multiple incoming targets. The integrated system was able to neutralize threats with minimal losses, not through brute force, but through speed, coordination, and predictive decision-making. This marks a shift away from centralized command and control toward decentralized, AI-driven responsiveness. It's no longer about one ship giving orders to another. It's about a system where each unit knows what to do, adapts to changes, and supports others in real time. Drone carriers also provide tactical versatility. While traditional carriers require significant time and risk to launch and recover jets, the drone systems on Type 076 ships operate faster, with less infrastructure and fewer failure points. They can be deployed closer to areas of interest without the same level of concern over vulnerability. And here's the strategic twist. These vessels don't need to broadcast their presence. With stealth drones, low radar profiles, and autonomous systems, they can silently patrol contested zones, gathering information and reacting instantly to changes. Their presence may not be known until after the mission is complete. Taken together with the radar decoys and unmanned surface fleet, these drone-launching ships complete a trifecta of modern sea power: deception, autonomy, and speed. This is no longer about replacing humans. It's about building a completely new category of naval capability.